Greetings from MWN.com. Dr. M. Wilson is happy to present this session of statistics. Please subscribe the channel MWN.com. Thank you. Chapter 14. Theoretical distributions. Theoretical distributions are related with the repetition of experiments. It analyzes about the number of times a particular event is expected to happen. It is associated with the probability of occurrence of events. The result of probability is in fraction. But the result of theoretical distribution is in frequency. It states that theoretically certain events will happen in certain number of times. For example, the probability of occurrence of any number when a die is thrown is 1/6. It is in fraction. If the die is thrown 60 times, the probability of occurrence of each number is 10 times. It is theoretically distributed as 10 times each for the occurrence of each 6 numbers. The probability of occurrence of head when a coin is tossed is 1/2. If the coin is tossed 100 times, then the probability of occurrence of head should be theoretically 50 times and tail is 50 times. This is called the theoretical distribution. But in practice, there may be variations in the occurrence of events. It is not possible to get each number exactly for 10 times when the die is thrown for 60 times. Also, it is not possible to get exactly 50 heads when the coin is tossed for 100 times. Hence, with the help of theoretical distribution, it can be determined that the experiment conducted is biased one or not. If the trial is of much number of times, it tends to be very close to theoretical distribution. If it is not close to theoretical distribution even for many more trials, then there may be bias in the subject or sampling fluctuations. Methods of measuring theoretical distribution. The important methods of measuring theoretical distribution are 1. Binomial distribution, 2. Poisson distribution, and 3. Normal distribution. Binomial distribution. A Swiss mathematician, named James Bernoulli, developed binomial distribution. Hence, it is also called as Bernoulli distribution. Binomial distribution means a probability distribution explaining the probability of one set of dichotomous alternatives of success or failure of events. Assumptions. 1. Dichotomous alternative. Alternative of success and failure is called dichotomous alternative. All observations should be classified into 2 categories, namely, those having a particular characteristic, success. Those not having a particular characteristic, failure. 2. Number of trials should be more than 1. There should be more than 1 trial for ascertaining binomial distribution. In each successive trial there should be dichotomous alternatives, i.e., success or failure. 3. Probability of success in each trial should be constant. The probability of success in each trial should be constant. The probability of success is denoted by P, and the probability of failure is denoted by Q. 4. Independent trials. All trials are independent. The occurrence of an event in the first trial will not affect the second and subsequent trials. 5. Identical trials. All the trials should be identical. 1. There should not be any variations between one trial to another. Formula for binomial distribution. The binomial distribution can be expressed in items by adopting the formula mentioned here. This formula is related to probability and the value of it would be less than 1. Total of all the outcome would be equal to 1. To obtain the frequency of, in sets of, in trials, the following formula can be applied. P equals probability of occurrence of an event. Q equals probability of non-occurrence of an event. i.e., P equals 1Q or Q equals 1P. The probability of occurrence of frequency of an event can be calculated as follows. It includes the number of times the expected events would happen. Characteristics of binomial distribution. 1. The shape and location of binomial distribution changes due to the change in the value of P for a given number of trials. 2. When the numbers of trials are increased, the distribution becomes very close. It may give a bell-shaped curve. 3. If NP is an integer, the arithmetic mean and mode of binomial distribution may be equal. This would normally happen for a largest probability distribution. 4. If n is large and p or q is not close to 0, then binomial distribution may be approximately normal distribution that is mentioned in the formula. Illustration 1. 5 coins are tossed 32 times. Find out the number of times 2 heads and 4 heads will occur. Solution. Probability of getting a head P equals 1/2. Probability of getting a head Q equals 1 minus 1/2 equals 1/2. Probability of getting heads in n trial is mentioned here. It shows the equation of probability into the number of items. In the chapter probability this concept is well explained. In addition to this equation of probability formula, n trial should be multiplied. I. Probability of getting 2 heads when 5 coins are tossed 32 times. Here probability is calculated through combination formula. Combination is n factorial divided by n minus r factorial. That is 5 factorial divided by 2 factorial. Easy method of calculation is that by identify he small value. Here it is 2 and hence in the denominator multiply is 1 and 2 in the numerator 2 values from the descending order should be considered. That is 5 into 4. Illustration 2. 6 dices are thrown 243 times. How many times do you expect at least 3 dices show a 5 or 6? Solution. The number of times at least 3 dices are showing a 5 or 6 in one throw is equal or greater than 3 means P3, P4, P5 and P6 since the total outcome is 6 for a die. Equals 243x equals 78 times. Fitting of binomial distribution. According to binomial distribution, the probability of 0, 1, 2, 3, 4, 5, n success would be obtained by the expansion of p plus q n. When the experiment is repeated for number of times then, the frequency of success can be calculated as follows. nxpr equals nxncrprqnr. Where n means number of times the experiment is repeated, r is the expected frequency of success, n is the number of outcomes, p is the rate of success and q is the rate of failure. The binomial distribution for different number of success i.e., r equals 0, 1, 2, 3, n, are shown as follows. Illustration 3. 7 coins are tossed 128 times. What are the expected frequencies of getting heads? Also tabulate the result. Solution. Probability of getting a head p equals 1/2. Probability of not getting a head q equals 1 minus 1/2 equals 1/2. The probability of success getting a head in our trial for one toss. The probability value which will be lower than 1. Hence, probability of our heads in the toss of 128 times is multiplication of probability value with 128. In the table the calculations are well presented. There are 8 outcomes and the central value of expectation is lies in the event of 3 and 4 heads. These values is 35 each. Below third event it is calculated as 21, 7 and 1. Hence above the event of 4, that is 5, 6 and 7 would be the same values. That is 21, 7 and 1. Hence the calculation of any one of above or below values need to be calculated. Since the total toss is 128, the total of the calculation should be equal to 128. Illustration 4. 8 coins are tossed at a time and the number of heads observed at each throw is recorded and results are given below. Find out the expected frequencies. Solution. In the above illustration the expected number of events, that is theoretical frequencies, are calculated. But in reality there would be some variations. It is well known from the illustration. The total events recorded is calculated as n equals 4 plus 12 plus 60 plus 100 plus 137 plus 113 plus 64 plus 20 plus 2 equals 512 total frequency. It is asked to calculate the theoretical frequency. P. Success. Q. Failure. P equals 1/2, Q equals 1/2, n equals 8 number of trial. It can be calculated as like the previous illustration. But in this illustration there are 8 coins. Hence there will be 9 outcomes including no heads. Hence the central event is 4 heads. Hence below that events are 3, 2, 1, 0 and above that is 5, 6, 7, 8. The expected frequencies for these two sections are equal 1. Hence, there is enough to calculate any one of sets for 3, 2, 1, 0 or for 5, 6, 7, 8. From that uncalculated values can be noted. Here expected frequency of 0, 1 and 2 heads are calculated. Here expected frequency of 3, 4, 5, 6, 7 and 8 heads are calculated. The calculated values are tabulated here. It is noted from the table that the expected frequencies for heads 0 to 3 and of 8 to 5 are same. Properties of binomial distribution. The following are the properties of binomial distribution. I. It has parameters. They are a number of outcomes n, and success p, or failure q. E. Arithmetic mean equals NP. E. Variance equals NPQ. E. Skewness beta 1 equals Q minus P square divided by NPQ. IV. Kurtosis beta 2 equals 3 plus 1 minus 6 NP divided by NPQ. It is symmetrical if P equals Q equals 0.5. It is positively skewed if P less than 0.5 and negatively skewed if P greater than 0.5. Illustration. 5. State whether the given data related to binomial distribution are consistent or not from the following data. Mean is 15 and variance is 17. Solution. Mean equals NP equals 15. Variance equals NPQ equals 17. 15xq equals 17. Q equals 17/15 equals 1.13. The value of Q should lie between 0 and 1. But the value of Q in this distribution is 1.17. Hence, the given data are inconsistent. Illustration. 6. The probability of the defective products from a production line of 3,000 products is 15%. Calculate its A, mean, B, standard deviation, C, skewness, and D, kurtosis. Solution. N equals 30 OOP equals 15% equals 0.15 Q equals 1 P equals 1 0.5 equals 0.85. A, mean equals NP equals 3000 by 0.15 equals 450. B, SD equals square root of NPQ equals 19.56. C, skewness, beta 1 equals Q minus P square divided by NPQ. D, kurtosis beta 2 equals 3 plus 1 minus 6 NP divided by NPQ. Equals 3.001. Illustration 7. Find out N, P and Q when the mean of a binomial distribution is 125 and standard deviation is 10. Solution. Mean M equals NP equals 125. Standard deviation equals 10. NPQ equals 100. Q equals NPQ by NP equals 0.8. P equals 1 minus 0.8 equals 0.2. N equals 625. Illustration 8. Obtain the binomial distribution for which mean is 30 and variance is 9. Solution. Mean equals NP equals 30, variance equals NPQ equals 9. P equals 1, Q equals 1 minus 0.03 equals 0.7. NP equals 30, N 0.7 equals 30, N equals 43. Hence, the binomial distributions is P plus Q raise N equals 0.75 plus 0.25 raise 43. Poisson distribution. Poisson distribution was developed by French mathematician Simeon Denis Poisson during 1837. Poisson distribution is a technique of ascertaining the probability of occurrence of an event when there is very rare change of occurrence of an event. It is applied when the probability of non-occurrence of an event is impossible to predict. Example. Poisson distribution is applied to test the probability of number of road accidents in a city, number of defective products in a mass production, etc. The probability of occurrence of an event can be calculated under position distribution as follows. P r equals m raised to r into e raised to minus m divided by r factorial. R indicates expected number of times an event occur. E indicates the base of natural logarithms. Its value is 2.7183. M indicates the mean of the Poisson distribution. It can be calculated as NP. N equals number of times, P equals probability. The probabilities of occurrence of various rare events, number of success like 0, 1, 2, 3, N, according to Poisson distribution are given as follows. P0 is the probability of 0 success. P1 is the probability of 1 success. Pn is the probability of n success. M is the mean of the Poisson distribution and use of E equals 2.71828. The formula given here shows that the probability of expected event is denoted as m raised the expected number divided by factorial of the same number. Illustration 9. It is experienced that 2% of the television manufactured by a company are defective. Find out total of 300 televisions will contain a no defective, B exactly 1 defective, and C exactly 3 defectives. Solution. Probability of defective, P equals 2%. M equals 300 by 2% equals 6. A probability of not defective P0 equals E raised to M. It can be known from Poisson distribution table given in appendix. B probability of 1 defective P1 equals m. E raised to minus 6 is calculated as 0.0025 and it should be multiplied by 6 equals 6 by 0.0025 equals 0.015. C probability of 3 defectives P3 equals like the previous calculation it should be calculated since the expected event is 3 then 6 rise to 3 and in the denominator 3 factorial should be applied. Illustration 10. It is known that 2% of blades manufactured by a company are expected to be defective. What is the probability that at most 6 defective blades will be found in a sample of 500 blades? Solution. The mean defective blade, M equals NXP equals 500 by 1%, equals 500 by 0.01 equals 5. e raised to minus m equals 2.71828 raised to minus 5 equals 0.006. E raised to minus 5 is known from the table. The formula for Poisson distribution is mentioned here. PR equals the probability of utmost 5 defective blades. Px less than or equal to 6 equals P0 plus P1 plus P2 plus P3 plus P4 plus P5 equals 0.0067 by 91.33 equals 0.61. Illustration 11. The past records showed that there were 9 road accidents on an average per month in a locality. What is the probability as per Poisson distribution, that in a given month, there will be less than 6 accidents? Solution. Mean number of success, m equals 9. Pn equals the probability of less than 6 accidents equals P0 plus P1 plus P2 plus P3 plus P4 plus P5 equals 0.00012 by 937.5 equals 0.113. Illustration 12. There are 300 mistakes pointed out from 100 pages typed by a typist. Find out the probability that a page contains at least 4 mistakes. Assume Poisson distribution. Solution. The mean mistakes from 100 pages equals 300 100ths equals 3. PR equals the probability that a page contains at least 4 mistakes equals 1 P0 plus P1 plus P2 plus P3 equals 0.0498x13 equals 1 minus 0.647 equals 0.353. Illustration 13. Out of the total nuts manufactured by a company, 0.5% became defective. The nuts are supplied in packets of 75 nuts. Find out the probability number of packets containing I, no defective, E, 1 defective, E, 2 defectives, IV, 3 defectives, V, less than 4 defectives and V, more than 4 defective nuts respectively in a consignment of 4,000 packets. Assume Poisson distribution. Solution. The probability of defective nuts. P equals 0.5% equals the mean probability of defective nuts. M equals Pxn equals 0.004x75 equals 0.3. Formula for the probability of defective nuts as per Poisson distribution in 4,000 packets is mentioned here. I, number of packets with 0 defective. P0 equals 4,000 x e raised to minus 0.3 equals 4,000 by 0.7408 equals 2,963. E, number of packets with 1 defective nut. P1 equals 2,963 by 0.3 equals 889. Number of packets with 2 defective nuts. P2 equals 4,000 by 0.0333 equals 133. IV, number of packets with 3 defective nuts. P3 equals 8. V, number of packets with less than 4 defectives. Equals 2,963 plus 889 plus 133 plus 8 equals 3,993. V, number of packets with more than 4 defectives. Equals 4,03993 equals 7. Fitting a Poisson distribution. The expected frequencies as per Poisson distribution can be calculated through a shortcut method, which has been stated as follows. In illustration 14, it is required to fit a Poisson distribution. Solution. Mean value is calculated through the table. NP0 equals 121.3. NP1 equals 60.65. NP2 equals 15.17. NP3 equals 2.53. NP4 equals 0.32. NP5 equals 0.03. Total equals 200, which is also stated in the illustration. Illustration 15. A sample of 300 air-conditioned sets are examined to find out the number of defective sets. The details regarding the number of defectives are stated as follows. Calculate the theoretical distribution on the basis of Poisson distribution technique. Solution. Mean value is calculated through the table. Theoretical distribution based on Poisson distribution is calculated and presented in the table. Properties of Poisson distribution. The following are the important properties of Poisson distribution. 1. Arithmetic mean m equals p. 2. Standard deviation SD equals square root of m. 3. Variance equals m. 4. Skewness beta 1 equals 1 by m. 5. Kurtosis, B2 equals 3 plus 1 by m. M equals mean. P equals the mean success in the Poisson distribution. Illustration 16. Calculate I, standard deviation, E, variance, E, B1, IV, B2, B, M3 and V, my U when mean of a Poisson distribution is 10. Solution. I. Standard deviation equals 3.16. E. Variance equals M equals 10. E. Skewness, beta 1 equals 0.1. IV. Kurtosis, beta 2 equals 3.1. V. Third moment, M3 equals M equals 10. V. Fourth moment, M4 equals M plus 3 square meters equals 10 plus 3, 102 equals 10 plus 300 equals 310. Illustration 17. State whether there is consistency in the Poisson distribution with mean 15 and standard deviation is 4. Solution. In the Poisson distribution, variance is equal to mean M. In the given distribution, variance equals standard deviation square, that is 4 square equals 16, which is not equal to the mean M equals 15. Hence, the given distribution is not consistent. Normal distribution. The binomial and Poisson distribution are based in the discrete probability distribution. But the normal distribution deals with the continuous probability distribution. The normal distribution was discovered by de Moivre, an English mathematician in the year 1733. The normal distribution is an approximation to binomial distribution. When the number of trials or experiment becomes large, the occurrence of an event P and N on occurrence of the event Q tends to be equal. In such a situation, the approximation of the events should be taken into consideration. The limiting frequency curve, so obtained, is called the normal frequency curve. The curve tends to be normal due to the greater number of repetitions of experiments. Hence, a continuous random variable x is said to be normally distributed, if it has the probability density function represented by the equation mentioned here. The graph of normal distribution will be a bell-shaped. The model of it has been shown as follows. Characteristics of normal distribution. The important characteristics of normal distribution are stated below. 1. The normal distribution curve assumes different shapes based on the different values of M and S mean and standard deviation. 2. The normal distribution is a limiting form of binomial distribution when the number of trials is very large. Properties of normal distribution. The important properties of normal distribution are stated below. 1. The normal curve is perfectly symmetrical about the mean. It is bell-shaped. If the curve is folded along the vertical line at the center, the two halves of the curve would coincide. 2. The mean, median and mode are equal in a normal distribution. 3. Skewness is equal to 0. 4. It has only one mode. 5. The first quartile Q1 and the third quartile Q3 are equidistant from median or mean. Q1 equals M 0.67 small sigma, Q3 equals M plus 0.67 small sigma. Quartile deviation equals 0.67 small sigma. Mean deviation, about mean, equals 0.90 s equals 4/5 small sigma. Small sigma is standard deviation. 6. All the odd moments about mean are 0. M1 equals M3 equals 0. 7. Kurtosis equals mu4 by mu2 square equals 3 small sigma raised to 4 by small sigma raised to 4 equals 3. 8. The maximum ordinate is at x equals m. 9. The area under the curve means the area lying between the curve and the horizontal axis. The standard deviation distributes this area as follows. I. Mean plus small sigma cover 68.27% area, that is, 34.135% area will lie on either side of the mean. E. Mean plus 2 small sigma covers 95.45% area, i.e., 47.725% area will lie on either side of the mean. E. Mean plus 3 small sigma covers 99.73% area. That is, 49.865% area will lie on either side of the mean. Standard normal distribution. In a normal distribution, the probability of the variate lying between two values can be found out. The number of observations in the interval between two values can also be calculated. For different distributions, there exists different means and standard deviations. Hence, the probability curves for different distributions will be different. It requires different tables of area under normal curve. These problems can be reduced if the general variate is converted into a standard normal variate. The variate is equally distributed about the maximum ordinate, i.e., mean, in the normal distribution. In the standard normal variate, an area to the left of origin corresponds to the probability of negative value of the variate, i.e., values less than arithmetic mean. The area to the right of the origin represents the positive values of variate, i.e., values greater than arithmetic mean. In standard normal variate, arithmetic mean equals 0 and standard deviation equals 1. Standard normal distribution is denoted as z distribution. It can be calculated as z equals x minus x bar by small sigma. The standard normal distribution satisfies the following condition. Area under standard normal curve. The area under standard normal curve depends on the mean and standard deviation. The graph of standard normal curve is presented as follows. The graph clearly shows that the total area is 1, x equals 0 and s equals 1. The area under normal curve can be calculated by referring the table corresponding to the calculated value of z. Value of z can be calculated as z equals x minus x bar by small sigma. When x is greater than, the area falls on the right side of the curve. When x is less than, the area falls on the left side of the curve. Illustration 18. Find the area under standard normal curve for between z equals 0 and z equals 2. Solution. Area for z equals 2 is 0.4772. This can be known from the normal distribution table. It can be represented in normal curve as follows. Illustration 19. Find the area under standard normal curve for between z equals 0 and z equals minus 1.7. Solution. Area for z equals minus 1.7 is 0.4554. It can be represented in normal curve as follows. The area is shown as minus value and hence the area is left side of the curve. It is noted that the total area is 1, hence on the left side total area is 0.5, that is 50% of the area. It is denoted as minus value since it is Bell 0W, the central value. Here minus 0.4554 is measured from the central place. The required area is shown in black color. Illustration 20. Find the area left of z equals 0.74 under standard normal curve. Solution. Area for z equals 0.74 is 0.2703. The area in right side is 0.2703. Since it is mentioned as left of 0.74. The required area equals 0.5 plus 0.2703 equals 0.7703. The entire area of left side should also be included. It can be represented in normal curve as follows. Illustration 21. Find the area right of z equals 0.74 under standard normal curve. Solution. Area for z equals 0.74 is 0.2703. Hence, the required area equals 0.5 plus 0.2703 equals 0.7703. It is just like the previous illustration but starts from the left side as it is minus value. It can be represented in normal curve as follows. Illustration 22. Find the area under standard normal curve for between z equals 0.74 and z equals 0.74. Solution. Area for z equals minus 0.74 is 0.2703. Area for z equals 0.74 is 0.2703. Hence, the required area equals 0.2703 plus 0.2703 equals 0.5406. Between toe z values form on both sides since one value is minus. It can be represented in normal curve as follows. Illustration 23. Find the area under standard normal curve for between z equals 0.74 and z equals 2. Solution. Area for z equals 0.74 is 0.2703. Area for z equals 2 is 0.4772. Hence, the required area equals 0.4772, 0.2703 equals 0.2069. This is because both values are on the positive. That is right side of the curve. It can be represented in normal curve as follows. Illustration 24. Find the area under standard normal curve for between z equals 0.74 and z equals 1.7. Solution. Area for z equals minus 0.74 is 0.2703. Area for z equals minus 1.7 is 0.4554. Hence, the required area equals 0.4554, 0.2703 equals 0.1851. Since both values are minus, the area lies in the left side of the normal curve. It can be represented in normal curve as follows. Illustration 25. The daily income of 900 people in a locality is normally distributed with mean income of 700 rupees and standard deviation of 110 rupees. Find out the expected number of persons getting income of I below 550 rupees, E above 770 rupees, E below 790 rupees. IV between 600 rupees and 790 rupees. Solution. It is not difficult to do such kind of problems if one knows how to identify the area in the normal curve. In all problems, the required area should be multiplied with 900 since the total number is 900. 1. Expected number of persons getting income of below 550 rupees equals 700, S equals 110, X equals 550. Z equals 1.3636. Area under standard normal curve for Z equals minus 1.3636 is 0.4131. Hence, area for below 550 rupees equals 0.50.4131 equals 0.087. Number of persons getting salary below 550 rupees equals 0.087 x 900 equals 78. Expected number of persons getting income of above 770 rupees equals 700, S equals 110, X equals 770. Z equals 0.636. Area under standard normal curve for Z equals 0.636 is 0.2389. Hence, area for above 770 rupees equals 0.50.2389 equals 0.2611. Number of persons getting salary above 770 rupees equals 0.2611 x 900 equals 235. Expected number of persons getting income of below 790 rupees. It lies within 0.5 of area on left side and area meant for x equals 790 on right side. Equals 700, S equals 110, X equals 790. Z equals 0.818. Area under standard normal curve for Z equals 0.818 is 0.2939. Hence, area for below 790 rupees equals 0.5 plus 0.2939 equals 0.7939. Number of persons getting salary below 790 rupees equals 0.7939 x 900 equals 715. Expected number of persons getting income of between 600 rupees and 790 rupees. It lies within some area on left side and some area on right side. Area on left side, x equals 600. Area on right side, x equals 790. Equals 700, S equals 110, X equals 600 and 790. Z for area on left side equals minus 0.909. Z for area on right side equals 0.818. Area left of standard normal curve for Z equals minus 0.909 is 0.3186. Area right of standard normal curve for Z equals 0.818 is 0.2939. Hence, area for income of between 600 rupees and 790 rupees equals 0.3186 plus 0.2939 equals 0.6125. Number of persons getting income of between 600 rupees and 790 rupees equals 0.6125 x 900 equals 551. Illustration 26. In a normal distribution, 15% of area is with 40 and 70% of variable is with 90. Calculate mean and standard deviation. The illustration is well represented in the diagram. Solution. When 15% of items are under 40, required area equals 0.5.15 equals 0.35. Z for area 0.35 equals 1.04. Through simultaneous equations, the values of arithmetic mean and standard deviation is calculated. Illustration 27. The marks scored by 300 students in the subject English of a college is normally distributed with mean marks as 55 and standard deviation as 9. Find out the expected number of students who got marks 1 above 70, 2 below 45, 3 below 65, 4 above 43, 5 between 43 and 67, 6 between 60 and 70, 7 between 37 and 47. Solution. It is not difficult to do such kind of problems if one knows how to identify the area in the normal curve. In all problems, the required area should be multiplied with 900 since the total number is 300. The area in normal curve is known from the area under normal curve table. 1. Expected number of students with marks above 70. Z equals 1.67. Area under standard normal curve for Z equals 1.67 is 0.4525. Hence, area for above 70 equals 0.50.4525 equals 0.0475. Number of students who scored above 70 marks equals 0.0475 x 300 equals 14. Expected number of students with marks below 45. Z is calculated as 1.11. Area under standard normal curve for Z equals 1.11 is 0.3665. Hence, area for below 45 equals 0.5, 0.3665 equals 0.1335. Number of students who scored below 45 marks equals 0.1335 x 300 equals 40. Expected number of students with marks below 65. It lies within 0.5 of area on left side and area meant for x equals 65 on right side. Area under standard normal curve for z equals 1.11 is 0.3665. Hence, area for below 65 equals 0.5 plus 0.3665 equals 0.8665. Number of students who scored below 65 marks equals 0.8665 x 300 equals 260. Expected number of students with marks above 43. It lies within 0.5 of area on right side and area meant for x equals 43 on left side. Z equals 1.33. Area left of standard normal curve for z equals 1.33 is 0.4082. Hence, area for above 43 equals 0.5 plus 0.4082 equals 0.9082. Number of students who scored above 43 marks equals 0.9082 x 300 equals 272. Expected number of students with marks between 43 and 67. It lies within some area on left side and some area on right side. Area on left side, x equals 43, area on right side, x equals 67. Equals 55, s equals 9. Z for area on left side equals 1.33. Z for area on right side equals minus 1.33. Area left of standard normal curve for z equals 1.33 is 0.4082. Area right of standard normal curve for z equals minus 1.33 is 0.4082. Hence, area for marks between 43 and 67 equals 0.4082 plus 0.4082 equals 0.8164. Number of persons getting marks between 43 and 67 equals 0.8164 x 300 equals 245. Expected number of students with marks between 60 and 70. It lies within some area on right side between x equals 60 and x equals 70. Z equals 0.56. Area under standard normal curve for z equals 0.56 is 0.2123. Z equals 1.67. Area under standard normal curve for z equals 1.67 is 0.4525. Hence, area for marks between 60 and 70 equals 0.4525, 0.2123 equals 0.2402. Number of students getting marks between 60 and 70 equals 0.2402 x 300 equals 72. Expected number of students with marks between 37 and 47. It lies within some area on left side. Z for area on left side equals minus 2. Z for area on left side equals minus 0.89. Area left of standard normal curve for z equals minus 2 is 0.4772. Area left of standard normal curve for z equals minus 0.89 is 0.3133. Hence, area for marks between 37 and 47 equals 0.4772, 0.3133 equals 0.1639. Number of students getting for marks between 37 and 47 equals 0.1639 x 300 equals 49. The exercise of this chapter is well presented below. Please subscribe MWN.com. Thank you. Please subscribe MWN.com.